Let's do distribution on number 4 before anything else. The left side becomes 2u squared minus 6u, and the right side becomes 8 minus 4u. Again, we need to set this equal to 0, put it in standard form, and we will have 2u squared. After we add 4u to each side, this left side will be up to negative 2u, and then subtracting 8 on each side, we'll have minus 8 equals 0. I do notice that I can factor a 2 out, leaving u squared minus u minus 4. And I can ignore that 2 out in front, or divide it off of each side, so it's gone. But now I've got to try and factor what's inside the parentheses, and I can't find two numbers that will multiply to negative 4 and add up to negative 1. I could complete the square or use the quadratic formula. Because there's an odd coefficient which is harder to cut in half and create fractions, I don't want to use completing the square. So I'm going to go to the quadratic formula and evaluate the discriminant. This will be negative 1 squared minus 4 times 1 times negative 4, which will be 1 plus 16, which is 17. Then I can move on to the rest of the quadratic formula. U will equal negative b plus or minus the square root of 17 all over 2a. And finalizing this, negative b, or negative of negative 1, becomes 1 plus or minus the square root of 17 all over 2 times 1, which is 2, and what I've written there is the solution set to this problem. Problem number 5 has a 4th power in it, and I'm not going to let that scare me. I'm going to factor with an a squared at the beginning of each parentheses, find out that my two key numbers in the parentheses are going to be minus 9 and minus 1, and further factor these difference of two squares into a plus 3, a minus 3, a plus 1, and a minus 1 equal to 0, and we will see that a has 4 possible values, plus and minus 3 and plus and minus 1. And since this was a 4th degree equation to begin with, we would expect to have 4 solutions to this problem. We notice in this next parentheses that t minus 4 over 3 shows up twice, first to the second power, second to the first power. So I'm going to use u substitution and let u equal t minus 4 over 3. I'm going to then make that substitution to have 2u squared minus u minus 3 equals 0, and that is going to factor easily into 2u minus 3 times u plus 1. So we can see very easily that u is going to equal 3 halves, or u is going to equal negative 1. But since this variable is supposed to be t, and we've changed variables out, we need to back substitute and go back to the letter t. So change the u on the left here to t minus 4 over 3, and do that for both of these equations, one time being set equal to 3 halves, the other side time being equal to negative 1, which I'll write as negative 1 over 1. Now I have two different equations which I can solve by cross multiplication. The first one will be 2t minus 8 equals 9. Adding 8 to both sides gives me 2t equals 17, and t will equal 17 halves. On the right, if I cross multiply, I'll have t minus 4 equals negative 3, and adding 4 to both sides, I will have t is equal to 1. Now both of these values should be checked, and they do if you substitute them in to the original problem. Number 7 has negative exponents here. You have a couple of choices. First, you could factor with x to the minus first at the beginning of each parentheses, and use the two key values, minus 6 and positive 4, and find out that x to the minus first equals 6, or x to the minus first is equal to negative 4. And then we could clear these negative exponents by raising each side to the negative first power, and multiplying those exponents, we get positive 1 on the left. So we would get x equals 6 to the negative first, which is 1/6, or x can be negative 4 to the negative first, which will be negative 1/4. Now, some of you may feel a little bit uncomfortable solving the problem this way, and you may choose to use the negative exponents at the very beginning to move those x's down to the denominator. If you do that, let me rewrite the problem. X to the negative second minus 2x to the negative first minus 24 equals 0. If we apply the property of negative exponents, we could rewrite this as 1 over x squared minus 2 over x minus 24 equals 0. And we could then clear out all the fractions by multiplying through by the least common denominator x squared, and that would give us 1 minus 2x minus 24x squared equals 0. If I brought all these terms to the right and put the 0 on the left, I'd have 24x squared plus 2x minus 1. And that is then factorable into 4x plus 1 times 6x minus 1, which you could then solve very easily to get those very same answers of negative 1/4 or positive 1/6.